If you have a 3D printer with one of these, a stepper motor, a coupler, and a lead screw, chances are you've seen Z-banding in one of your prints before. Z-banding is caused by a misalignment of your lead screw. Whether if you have one or two, it's whenever the lead screw is in one direction and you get current results like this that I'm about to show you on screen, where you have a pattern that goes back and forth inside the print and it matches the pattern of your lead screw. There's an easy way to fix this, and I'm going to show you how to do that today, and that's by pretty much changing your coupler. So, like I said, it's any misalignment of your lead screw. So as long as your lead screw is straight, your coupler is bad. But if you can see, it's leaning to the right now. If I rotate it, it'll go forward, and then it'll lean to the left, and then go backwards and lean to the right. The other one I accidentally bent as well, but I was able to bend that back with 2 pairs of screwdrivers. This one I was trying to bend with it still being on the stepper motor, and that's not a good idea. So instead I decided to entirely revamp the way that the couplers work on the system. It's actually fairly simple. All you need to do is have 1, 2, 3D design, a working 3D printer, whether or not you have Z-banding or not, and patience. Lots and lots of patience. And lots of patience. And don't forget that you also need a tap and die that's the same thread as your lead screw. So the first thing you want to do is open up 1, 2, 3D, grab your dial calipers, and grab one of your old couplers. And you're going to want to take the dial caliper and you're going to measure across the diameter. Now this one, roughly, is 0.8 of an inch in diameter. So I'm going to select the sketch tool for the circle, click on the plane I want to do, sketch the center, and then the diameter is 0.8 for me. This is different for most stepper motors and most couplers. So after you have your circle on the build platform, you're going to want to take the diameter of your shaft. Haha, I know. And so just take one of your stepper motors and do the same thing with the dial calipers. Just make sure you have the actual diameter of your stepper motor. And that one is 0.2. And so specify the center and 0.2. You're going to make a square that's half of your diameter, or just your radius, and it's going to go from the center downwards. And so this is going to make the 2 lines tangent to the circle so that you can cut a perfect line into where your stepper motor shaft fits. But you see where the stepper motor gets flat at that one spot? Right there and right there. Make sure that it is perpendicular, and you're going to measure it like this. From the corner of where you just made the tangent square, click there, and now you're going to do 0.19 by 0.2. So that'll make the left side of it tangent and the right side of it with a 0.1 offset. Now, this is the way that mine is designed on my printer right now. There is only 1 cut on the shaft. But on this one specifically, there's 2 cuts on the shaft. Because I just did this one, I'm going to do the other one now. I'm going to see what the diameter of this one is. So I go back into the CAD program, sketch a rectangle, select the distance I want, and so now where I just made the tangent line before, I'm going to do 0.18, and where I made the offset before, I'm going to do 0.2. You can see kind of where it fits over the shaft. And all you're going to do now is go to the trim tool right here, and you're just going to click on the sketch, and you're going to select all the entities you do not need. You've made 2, or actually 3 squares that go to the outside, so you don't need any of those. You pretty much don't need anything that is not inside the circle itself. And a lot of what CAD modeling is just a whole bunch of reference geometry. So you don't actually design anything in real time with what you're doing. It's more of just the references of what you want. you can hit enter to finish the trim tool. And so now you have the base of your coupler. So now what you're going to do is you're going to take the extrude tool, you're going to select just the outside entity because the shaft needs to be cut out. And I go up 1/2 inch. What you want to do is you want to go up 1/2 inch on the coupler, and that's going to be 1/2 inch that's stuck on the shaft. And if you want to make this, well, symmetrical, you put 1/2 inch on the shaft and 1/2 inch on the lead rod, or the lead screw. I'm just going to do a reference geometry where I go over here and I say project. It's the furthest thing in the sketch file. You're going to click that. You're going to click the object you want to have the sketch projected onto. You're going to click this, and then I just want this circle, just the circle. And I'm going to hit enter. I'm going to click the sketch, hit the middle. And what's really cool about this CAD program is that you can switch back and forth between inches and metric. I know that the diameter of my rods are 8 millimeters, and I'm cutting a hole into it with a tap. So instead I can just do 7 millimeters. And you saw it go to 7 inches, and then when I typed in mm, it went to millimeters. And then when I hit enter, it'll convert it to inches for me, and then I hit enter again, and now the circle's there. So now you just hit the extrude tool again from this plane, and you're only going to extrude the outer area, and you're just going to go up 0.5 again. And there's pretty much the bottom of the coupler where it fits into the shaft of the stepper motor, and this is the top where you're going to thread a hole for your lead screw. And one of the best things that I realize that should be done, and so you're going to go to the bottom of the object. You can go to the bottom or the top. I just prefer the bottom because there's a sketch down there already. So there's no reason to project another sketch on the top. Work smarter, not harder. Cliche, but it's true. So you're going to make the first rectangle, or first leg of the rectangle, the same length in diameter of your coupler. Then you're going to want to take 75% of your radius, I want to say. So the radius is 4. We're going to go up 0.3. When you hit enter, it creates a rectangle that's offset inside. Do it again on this side. Same way. You're going to want to go over 0.8, or the diameter of your coupler, and you want to go down 75% of your radius. So the radius is 0.4 because my diameter is 0.8, and 75% of 0.4 is 0.3. So after you get here, go to the extrude tool again. It's the exact same extrude tool as before. And you're going to click on the 2 entities that are on the outside. And when you tell it to extrude, and just give it a big number like 5 inches, you see 2 red lines cut through the object. And the 2 red lines are a subtractive process on the additive process you just made. So when you hit enter, the outside disappears. And so now that you made the coupler, hit save. You can either hit Control S, or you can go down to save and then to my computer. And then you're going to export this as an STL. And you're going to hit OK. Then I'm going to name this couple for video. Now I'm going to go over to Cura. And so file, load model file, and then just go where you saved your documents, and couple for video. So it takes about 30 minutes to print the coupler you just designed on your own, I hope. And you now can use this on the printer. And so after it prints out, I'll show you how to install it.